Hi, welcome to Teardown Tuesday. Yes, we've got a rather mundane item for you today. It's a cash register. I scored this one from the dumpster downstairs and well, I thought, you know, why not? I don't think there's going to be a huge amount in here. There's a thermal printer, there's a keypad, there's going to be a processor inside, there's a display up the top here and a vacuum fluorescent display on the bottom and the cash thing, which I don't have the key for, and it does actually work. It is fully working. It obviously came from a nearby cafe or something who got rid of it. Well, I thought we'd crack it open and have a look. You never know your luck. Now this one's a Quorion brand, if I'm pronouncing that correctly. It is German and it's the QMP 3282, and obviously it has this customizable keypad here, which obviously you can actually get the overlays in here. There we go. It looks like it's had a couple of overlays and you can just print these out yourself and presumably program it yourself, and it looks like they've had a couple of goes at that. So there you go. Maybe you can see prices change over time and stuff like that, and really there's the overlay on the bottom, and that's pretty much fixed. Is that stuck down? Yeah, it looks like it doesn't feel like a quality tactile dome, that's for sure. So I might actually try and prise that off and have a look to see if they do have a proper metal dome in there. Feels very spongy and no tactile feedback at all, but you'd think that they'd have to be pretty good quality to, you know, last in an environment like this. And obviously you've got the full rubber membrane on that because you're working in a cafe. There's spillage and all sorts of grime and grot all over the place, and there you go. But there it is, made in Germany. Awesome. Thermal printer, doesn't have any paper in it, but anyway, let's have a look. And on the back here, it's definitely seen better days. Anyway, it's got a PC input, presumably like a serial port, and a scanner, probably another like a serial, maybe a custom interface, I don't know. And a vacuum fluorescent display on the back. I won't bother powering it up because that violates the rule. Don't turn it on, take it apart. But yeah, I have, and it does work. Now, because I didn't have the key for this thing, I thought I'd have to pick the lock to get the cash tray out, but as it turns out, just get your finger in here and lift that up and bingo, out pops the tray. There you go. I'm not sure if all cash registers have that, but this one certainly does. And we're in like Flynn, look at that. Obviously it's got a solenoid in there that actually releases a catch. I can push that back in, but then it locks in place, of course. Get the software to actually release the mechanism on that thing. And this tray just pops out. It's all crusty. I haven't bothered to clean that, and hey, looky what we have here. To change price, key to P to scroll through products, cash in, PLU to finish. There you go. Somebody's written some notes, and how to take daily totals, and how to add to account, blah, 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 blah. But nothing else hidden in there. And there's a solenoid in the back of this thing. There's a spring and the catch under there. You can get your finger off there, but there's a cable then going up through to the top there, which the process can then activate when you go open, when you finish the transaction and open the cash to draw. I'm not sure exactly how to get this top part here off. It sort of, oh yeah, could be a couple of screws inside here or something like that holding it in. No, hang on. As it turns out, there's a thumb screw underneath here like this, and you whip that off and ta-da! Look at that, we're in. And that membrane keypad was stuck down on there, and I just peeled that off in one piece, and I just pulled these straight out. I didn't have to get into the boards. Of course, these aren't, they're just held in place by friction, that's all. So you can just pull those out through the slot on the top here, and I don't know, you might keep that for some sort of, I don't know, interactive project or something like that. It's nice that it's clear and see-through, so I think you'd keep that more for the things that you can't think of, those sort of hack projects that you have no idea about yet, but might come in handy one day. And what do you know, I found the key. Look at that, doesn't look too secure. And of course that bottom tray was earthed too. That would be a local safety requirement to have that metal tray earthed, and I've just undone the screws there, and ta-da, we're in. Awesome. Oh, interesting. And there's our main processor board. It's interesting that they've got two, they've got a daughter board sitting on top of that, so we'll have a closer look at that in a minute. And they've got a ribbon cable going over to a serial board at the back here. Obviously that looks like an Altera Max PLD on there actually, and then power supply under here with a nice little plastic cover on it. I rather like that. So that's the main switch mode supply, and we've got some ferrites there, cables wrapped through there, a couple of turns just to take the edge off the EMI there, and that's a key switch on the side. Actually, that's probably what the that might be what the key is to change the modes actually on this thing. Rather, it's got a mode switch on the side rather than the cache tray. I'd have to actually try it. Yep, that's the key for the mode switch. There you go, not for the cache drawer. That's why I found it inside the printer compartment in there. They kept it in there. I don't know, this is like to set it up or something like that, put into different test modes or, programming modes or whatever. You'd have to read the manual. Now, of course, when you do teardowns like this, you're always looking at what sort of parts you can salvage, and there's a very nice little vacuum fluorescent display module there, complete with all the driver stuff on the bottom. I don't know if you'd be able to get any data on that, but you could probably figure that out. I mean, it's only, there's not many wires on that interface there, so that's a really neat board. And of course, the good thing about this interface here is that, well, you've already got the working unit, so you could get in there while it's operational and actually probe these pins and work out what data format. Obviously it's some sort of serial type thing, or 4-bit interface or something like that, so shouldn't be too hard to reverse engineer that at all. Wouldn't take that much time if you wanted to reuse that. That's a nice looking module. Ah, beautiful. And they've actually put this ferrite on as before they've installed this thing. How do I know that? Well, they got a nice big cutout here in the case where that ferrite actually pops up through. Otherwise you wouldn't be able to get the damn thing up through there. And bingo, more salvage. Look inside the display. We've got ourselves a PowerTip LCD module. They're a known brand. It's got the part number on there. No doubt you can get the data for that. And yep, I just checked. You bet we've got the data sheet for that thing. Fantastic. It turns out this is a standard Hitachi pin-out LCD interface you're familiar with, but the extra pins 15 and 16, which are normally the backlight pins, they're actually chip select, so 2 different pins. And then a reset pin, I think is pin 17, and then a couple of others, which, yeah, so perfectly usable. Oh, what a great score. Well, hello, look what we have on the back here. That's a bit how you're doing. They've bodged something in there. I'm going to take a closer look. Aha, it's a 5-volt under-voltage sense chip. It's a Motorola MC34164P-5. That's a 5-volt version. Also comes in a 3-volt version. What's that? Basically a reset chip, which gives a reset output for this thing. Go into the reset pin when you get under voltage. So obviously some sort of hack here where they've had an issue with this product and some sort of bug or something like that. They couldn't be bothered fixing, the power supply's not ramping up fast enough for this thing to reset or something like that. They had issues with this particular LCD chipset in terms of reset and power on, and they've added this reset circuit for under voltage lockout. So, or they've got, for power glitches or something like that, the LCD might not reset properly and might switch off or get corrupted or something like that. So they've bodged on this reset chip. Interesting. And there's that Altera Max PLD I was talking about, EPM at 3064 there, so, fairly old school PLD. Aha, and there's our RS232 driver there, HIN2W1, old school intercell stuff. There's an interesting way to clamp your wires down. Look at that. That actually is strain relief and sort of clamp. That actually works pretty good. I like that. But it's clearly bodged in there because this is one of the standoffs for the rear board here. So yeah, they just haven't used that, and it was molded in. There's a matching one over here as well. So yeah, maybe a bit of an afterthought. Now if we have a look at the main board here, this daughter board on top is actually directly soldered in with that dual inline pin header, so they haven't actually bothered to put a connector in that. That's rather disappointing, so you can't get that bastard out without desoldering the whole blinking lot. How annoying. Anyway, what we have here is an Altera Max PLD again, and there's two more on the bottom board underneath this, so they're really going to town there. And then we have an Atmel AT89C52, so it's an 8051, a fairly modern 8051 processor. So that's what's running this top board, which is of course the thermal printer board. That's the thermal printer interface there. So that is so they've decoupled the functionality of that from the main processor under here, and they've got those two there, Max 2 PLDs, or Max PLDs, and not even Max 2. Need to have a look at that puppy there. And we've got ourselves an STL6219 stepper driver, stepper motor controller there. And up here is an L293. That's actually a quad push-pull driver. It can source basically 1.2 amps peak on all 4 channels. Not a bad little beast at all. And that's basically exactly what you need for a thermal printer interface. You need the push-pull driver up here for the heater, for the thermal heater, and then you need the stepper motor driver down here as well. And presumably they've decoupled all of the hard task of actually controlling the thermal printer into the PLD here. They're not doing it all in software up here, so you can see the traces actually running back down here to the Max 2 Max PLD. It's not a Max 2. Keep calling it a Max 2. It's an Altera Max. It's the original. And that RDC R8820 under there, I had no idea what that was, but it turns out there's an RDC semiconductor company, that's their name, and this R8820 is a 16-bit RISC DSP processor. Who the hell's ever heard of that? And it didn't make any sense for it to be like its own architecture or whatever, and it turns out it's not. It's software compatible with the Intel 80C186. So there you go, 16-bit 186 processor, just from a a cheaper, more obscure company, and they've probably risked it, or they've sort of like re-engineered it, but it is software compatible, so you can presumably use all the software tools for the 80C186 to actually develop is software for this thing. So there you go. As I said, 2 other Max PLDs under there. Whoop, there and there. So I don't know. They're driving all of this, and I don't know, they're doing they're offloading lots of tasks from the 2 processors in here. The main processor down the bottom, the top one, 8051 controller, just controlling the thermal printer up there. So they've really offloaded those tasks, all that glue logic and stuff like that, stuck it all together in those PLDs. They're probably not massively complicated, but worthwhile to, because ultimately there's not much else in here, but you don't really need anything. I mean, you need a processor, you need some RAM and some ROM, and you need a driver board for the thermal printer, but apart from that, and a communications interface, but apart from that you don't really need much else. So I'm not entirely sure what they're doing in those 2 Max PLDs on the bottom there. And that makes sense. A nickel metal hydride backup battery there, 70 milliamp hours, little tiny little thing that charges up. This explains why when I booted this thing, it went through an entire boot process and did all sorts of resets and calibrations and all sorts of stuff, and when I powered it up a second time, it just instantly, and that took some time to boot up. When I powered it up a second time, it just booted up instantly. So obviously it yeah, that was dead flat. Of course, you'd expect it to be. And that there looks like a decent little quality switch mode controller. I like that. It's well laid out, and looks like it uses quality parts. That's really quite nice heat shrinking around the input. Looks like a small common mode choke there, and all the power resistors are all, the diodes, everything all raised off, and that is really quite nice. And Nippon Chemicon capacitors, no worries whatsoever. Yeah, Nippon Chemicon again. no dramas whatsoever. So that's nicely engineered. Look at that. That's pretty decent. Good on the Germans. And this is interesting. Look at these two black wires here. These go off to the thermal printer, but they're not a supply output. Take a look. It's 2 ground pins, so they're actually getting high current return ground coming back from the thermal printer instead of it all traveling through that digital board there. So they've got the power running over, but then a separate ground loop running back just for the thermal printer, so you don't get all of those current pulses going through your ground plane on your board. It's a digital board, and primarily, so it shouldn't matter too much, but yeah, they determined that, yeah, that was the best course of action, is to return the ground from the thermal printer, so all the power, the power and data comes in here, but they're using this wire as the return ground path. Neat. And they've done this right. Look at this big ass earth strap going across here like this over to the main plate up the top, all nicely crimped and screwed into place. And yeah, that's, yeah, earthing on this thing's done right. Aha, that ground return, a bodge afterthought. Look at this. They're obviously skipping some, they need an extra low impedance path from there to there, and they've bodged on this connector, which is that return ground. Oops. They found that, they designed and built the thing and then found that, they were getting some issues with their board and probably scratching their head for a couple of weeks trying to figure out what was going on. And then some poor bastard traced out the ground, and well, there's an internal ground plane in here, but then they were probably getting some excess ground bounce on there or something like that when this printer operated, this thermal printer, and yeah, they decided, well, to fix it, well, we're not going to respin all of this, are we? No, and have separate return paths on the inner planes and stuff like that. No, bugger that. We'll just put some extra low impedance path in there, and then just return this to those spare pads that they had on that power supply. All right, I was going to say it was well engineered. It's a bodge. Now, I guess it depends on what you're into, but I personally wouldn't save that thermal printer module. I can't think of a good use for that. There's a little contact switch down in there. There we go. That's neat. Yeah, I don't know. Not really worth salvaging. I don't know if you guys do actually keep something like this when you tear us apart. Tell us apart and tell us why. But yeah, I know the answer, because I answered it before, in that it's for those things you can't think of, right? Alright, we'll hoard it. Caution, do not touch the flat oval plate. What's under here? Ooh. Scored a nice little stepper motor out of that. Yeah, that's a keeper. That goes in the motor box. And there is the thermal printing head on this thing. That's the header that connected up to it. And you can see that they've got some drivers gunked down on there, some chip on board stuff happening down there, and I'm not sure how many pixels, if that's the correct term, dots across there that one is. I might be able to get the macro lens on that. Oh wow, look at that, we can see it. There we go, you can see the individual lines like that. Look at all those fine traces. I can barely see this on the LCD screen of my camera. It'll probably show up really well in full HD, but you can see that each one of those chips drives, however, if anyone's keeping count there, drives however many dots on that thermal head there. So you can see the chip all gunked up inside there. But yeah, it'd be interesting to get a data sheet on one of those driver chips, that's for sure. So there you have it. That's inside one of these thermal printers, and they're rather interesting. I haven't had a look at in detail inside one of these things before, but fascinating stuff. If anyone does have any data on these things, then please share it. And this one's fancy pantsy. It's got a paper cutting mechanism on top. I just prized that open, and there's the paper cutter there. It's angled to slice more easily through the paper, and that's just driven by this worm drive here on this motor. Nice. So no, you know, the cheap ones will just have like a perforated edge on the outside where the motor just spits the paper out and then your user has to tear it off. This one actually cuts your receipt for you. Ooh. Actually, I'm rather inclined to keep that as a complete mechanism like that, because it's not often that you'll be able to, you know, get something that just shears off, something like that based on a motor input. So, yeah. Anyone got any creative uses for that? So there you go. I hope you enjoyed that Teardown Tuesday, and even something mundane as a cash register, you know, contains some fairly decent processing in it, and you can salvage some nice parts from it. You get a couple of motors, you get a cutting mechanism, nice vacuum fluorescent display, that's just beautiful, a nice reusable 128x64 dot matrix display, a power supply, nice power supply you can reuse, main switch mode job. Well worth the salvage. So there you go. As always, the data sheets for the things I found in this will be linked in down below, so check it out, and if you want to discuss it, jump on over to the EEVblog forum, or you can always leave a YouTube comment. Yes, I do read all the comments, or you can leave a comment on EEVblog.com, however you prefer to do it. I do read virtually all of them, and I try to respond where possible. By the way, if you do want me to respond to your comment on YouTube or wherever, generally within like the first 24 or 48 hours of uploading the video, I'm going to be checking the comments on that video. So, you know, there's more chance that I'm going to reply there. Anyway, I hope you enjoyed that, and if you did, please give it a big thumbs up. Catch you next time.